All right, have the mic on. I'll start talking right at 7. It's about 20 seconds here. Good? Okay, I'm good. All right, thanks for checking in here. We're going to talk about some stuff from a few years ago and go over the storm we had back on October 30th. You may remember we had 100-mile-per-hour winds hitting some folks in northeast Kansas as a microburst. Probably some gust natives hit areas from Frankfort to Vermilion up to Sabetha. We had a large area there with a significant amount of damage, and oddly enough, there was not a warning for a lot of that. So I want to talk about kind of how that could happen and show you some of the history of that storm and something similar that happened a few years ago. So this video is from Topeka back in July of 2018. This is from the Jayhawk Tower downtown. You're looking to the east-northeast, and what you see right there is all dust. We had extremely dry conditions the spring and most of the summer of July of 2018. You can see this is all, it's time-lapsed, but you can see how fast the dust is blowing. That's north of the Kansas River where most of that dirt is flying. Downtown, a lot of concrete and buildings. You don't kick up a lot of dirt there, but just north of the Kansas River, there's quite a bit of areas where you could kick up plenty of dust. There's even farmlands in the northwest of town as well getting tossed into this dust cloud that's whipping across Topeka. So what I want you to notice about that is that cloud is not attached to this cloud. It is not this is not an updraft that's connected to the base of the storm. So while you see things flying there, no doubt if you were close to this, you would see little areas of swirl. It wouldn't be a tornado. No way. It's a microburst, and a strong straight line winds combined with an area where the conditions were extremely dry. So going back to the USGS drought monitor back in July of 2018, look at this area of darker maroon there. That's the top end of the drought categories. Many of us were in severe drought. That's extreme drought, and all of this being severe drought. So many of us were extremely dry, and then we had this microburst come through Shawnee County and kicking up this just wild storm that looked like something from the Dust Bowl videos that and Dust Bowl pictures you've probably seen. So that was back in July of 2018, and just a day that I certainly won't forget. So how is that similar to what we had coming through areas like Vermilion and Frankfort and even Seneca back on the 30th? Well, it was definitely a microburst. This is a unique microburst because most likely it was several microbursts one after the next. Gust nados can form just in areas that have strong straight line wind. A gust nado is very similar to a tornado, except for it's not connected to the base of the cloud. It's not getting the jet stream winds to pull it along and really cause the upper level damage or significant damage. They can cause damage, no doubt, but they're not the same as tornadoes. They're formed by things that are going down low. So we had 100-mile-per-hour winds, dry and dusty ground that contributed to the visual appearance of the microburst. Many times if you had a microburst and it's been raining and soggy lately, you wouldn't see all these wild images that we saw out there. So what you saw a lot of times with the dust blowing around, it just looks really wild. That's not a condensation cloud like you see with a lot of tornadoes. It's a lot of dirt that was flying. So probably some gust nados with this. I think we had several, and the severe storm warning was likely delayed due to a radar weakness I want to show you here. All right, so storm spotter reports. Around Frankfort, we had some strong wind at 12:16 p.m. on the 30th. Over Vermilion, 100-mile-per-hour winds. We had damage there to a house, a lot of damage, and somebody even had an injury from that. So this area isn't particularly far from the National Weather Service radar. It's close to Alma, but 50 miles away does have some limitation. The farther out you get from the radar, somebody mentioned to me on Facebook, with the technology we have, surely you could see it, and we have great technology, no doubt, but the Earth is still curved. So if you have a radar in Alma aiming 50 miles up to the Vermilion and Frankfort area, the tilt of the radar that day was at half a degree. Half a degree is pretty low, but still at Vermilion and Frankfort, you can't see below 5,000 feet. That's the bottom of the radar beam, and the radar beam itself is actually more than a mile wide at that point. So I kind of made a graphic here to show what it looks like. There's just a symbol for the radar tower there. We're going to take the radar beam and spin it around. Once you're 50 miles out, this thing's going to be way up in the cloud. So you're not going to see all the processes going on down low. If it was a tornado in Vermilion or around Frankfort, we could see spin in the low and mid levels of the cloud. We can still see that stuff. but the microbursts and downbursts and that kind of thing, they happen much lower in the storm. And in this case, because the microburst was happening in an area that was dry, there was no precipitation to track with it. You have to have some sort of moisture in this to see it, or debris if it's kicking that up. But even dust doesn't show up on the radar. Mist and sprinkles don't always show up on the radar. You have to have real raindrops or some hailstones, something up there to see. If it's just a strong wind, strong motion in the clouds, we can't usually see that. Or if it's even dust that's being kicked up, we usually can't see that either. So problem number one with this, the radar is 50 miles away from Vermilion, which most of the time isn't a problem if we're dealing with tornadoes or big hail or something like that. But the other problem being that radar does not see dust or dry wind. So if you have extremely strong winds, it's not just going to pick that up. And again, the bottom of the beam at 50 miles at a half degree tilt is 5,000 feet up, and that's the bottom of the beam. So the beam is starting at 5,000 feet, but actually that's not the whole thing. It's not a skinny beam at 5,000 feet. It's 7,000 feet wide starting at 5,000 feet. So I'm not seeing all these processes going on down low. Now the Weather Service has a lot of great radars, but they're actually adding more. There's a company called Climavision that's actually working to add more radars around the area. They're working with the National Weather Service, and they may be able to warn better for these kind of things. They're adding a radar near Beatrice, Nebraska. They're adding one near Humboldt, Kansas. There's already one there. They're adding one near Hayes as well, and Russell. So these folks are adding more radars. They're a private company, but they're working with the radar service, the Weather Service, to provide more radars. So again, the farther you are away from the radar, you can't see as much, and the beam quality is not as great. But these folks keep adding these new radars. That will certainly be a big help. So here's Frankfurt, near Frankfurt. Karen's daughter sent this one in, and you can see the strong winds there. This is really the beginning of the storm, the earliest video I saw of this. And all that you see right there, this is dust being kicked up, and certainly it's extreme. The winds are at least 60 miles per hour. There was not a severe storm warning at this time, and all these processes are going down low. It's not a tornado from up at cloud level that's coming down. It's a microburst coming down from the bottom of the cloud and then blasting up all this dirt, which certainly once it starts getting kicked around, it looks impressive. It looks scary, no doubt, and it did cause some damage. But again, it's not a tornado. There may have been gustnadoes, but just really impressive stuff that was out there. This is the worst thing that happened. Certainly, this folks near Vermilion, there was no severe storm warning. There was no tornado warning. This is terrible. These folks in near Vermilion had their home just destroyed and somebody getting an injury there without a severe storm warning or tornado warning in place. And I don't want to make any excuses for it. I'm just telling you that with the radar, you can't see that thing down there. Certainly something could have done better to get these folks noticed quicker, but that's how it is. These microbursts, sometimes you just get very little warning and sometimes none. Here's the other side of the home. So what you're looking at a moment ago, the area is torn up, is over on this side of that wall. So this part of the building was all just ripped off, and somebody was in there and did get a head injury. And the winds were not measured, but estimated there by the Warning Coordination meteorologist, National Weather Service, Chad Omit, who said the winds are about 100 miles per hour to cause that kind of damage. So that was 12:18 p.m. near Vermilion. I'll keep tracking the storm. We go to the northeast. We got just south of Baileyville, and somebody had video there. This is video from Allison Steinlage, and all these images were submitted to WIBW.com into the Weather Pics section. So if you go to the weather page, go to Weather Pics, you can see pictures and videos other people submitted, or do some of your own. Look at that. Looks like a tornado to me, right? It's not. It's not connected to the bottom of the cloud. It's the winds are coming down from the cloud, blasting up dirt. And when the wind hits the ground and hits all that dirt, it's not going to blast it into the ground. It kicks it, and then the dirt starts flying, so it looks like it's going up, and it may get back to the base of the cloud. But it's not a tornado that's coming. It's not the base of the cloud connecting the ground. It's the winds are coming down from the cloud, blasting the ground, and sending that dirt back up. If it wasn't so darn dry, you probably wouldn't see these processes at all. So again, I'll go back and start that one over again. And you can see it looks, it looks intimidating. It looks like, that's something that you might think was a tornado, especially the right part of that, but it's not. And it may even be a gustnado, but it's definitely not a tornado. That's not what you're seeing there. Again, it was south of Baileyville, about 5 miles. So there's a big area where the winds are just blasting and the dust is kicking up. But over here to the right, that looks like a small enough area. That looks, like, oh, sure, it's a tornado. But it's probably just dust. You can see it's connected over here to other dust. And if it was a gustnado, maybe. But it's almost surely just dust is being kicked up from an area that's particularly, easy to kick up dirt, make it fly. So far to the northeast, Seneca got into this at 12:26 p.m. The Weather Service actually issued the first storm warning for this at 12:36 p.m. So we had winds to 90 miles per hour in Seneca. Same thing. It's microbursts. They're down low. You can't see them on radar very well, but it's causing all kinds of trouble at this point. 90 miles per hour winds in Seneca. Here's how that looked. This is video from Clinton. Just absolutely amazing there in Nemaha County with this. And again, dirt flying everywhere, and a lot of it because of the drought conditions we've had. If we had a lot of rain before these storms came through, we probably wouldn't see all those processes going on. The other thing is that if we had rain with the storm, you'd be able to see the motion of it and be able to tell where the severe storm winds were. But in this case, because the microburst was outrunning the rain, it was very difficult, if not impossible, to pick up on radar. Had a 77 mile per hour wind with an anemometer reported right there at 12:40 p.m. just southeast of Seneca. Then the storm, this is another video, that's from Clinton Myers again, there in Seneca, 12:26 p.m. And the wind's about 90 miles per hour there in town, just unbelievable, really. Here's another video from Emily in Seneca, about 12:30. You can see those wild winds coming in. Again, there's no rain with this. It's down the very bottom part of the atmosphere, just above the ground, so the radar does not see down to this level. I know it sounds strange, but the stuff we're watching with tornadoes and all of that, that's up higher. We're watching that motion that's going on above you, and in this case, with a microburst, especially a dry microburst, no. That looks like a tornado to me, right? It's not. It's the side of a building. You've got a building there, so the winds are whipping by 90 miles per hour. This part of the building is blocking the wind, so it just circles around. There's an eddy that's sitting right there, 90 mile per hour winds swirling around with the dust flying. And you can see up high, there's not as much up there, it's kind of bright, but the down low, all the dirt and dust from down low is all swirling and just looks really wild. I mean, no doubt that looks like a tornado. It's not. It's absolutely not. And again, because it was out of the rain, it's harder to pick up. Sabetha, Berwick, you were in the severe storm warning by the time it got over here. So 80 mile per hour winds, and these are some of the images we saw there. This is from Debbie, who was on her way home at 12:43. You can see the same thing, dust being kicked up there. This is all dust. It's not connected to the base of the cloud. Again, not a tornado. This is all straight line winds right there around Sabetha. There may have been a gustnado around Sabetha with this, and I'm pretty sure there was, but there was not an actual tornado with that. And gustnados are really short. They don't last very long at all. From Sabetha again, Ken, this is just about 12:46. You can see the extreme winds coming into the downtown area there in Sabetha with that extreme storm. And then Debbie started heading home. This is her right there. Showed the video from her a moment ago. As she gets home here, you're going to see Poe comes out. That's the dog. Poe is fine, and Debbie assures me that Poe is spoiled and she's a good dog, and she always comes out to greet her. And I looked at the roads here. This is not a through street or something. There's not a traffic here. So, out in areas like this, it's not uncommon for people, for folks to have the dog out. So that's not an unusual thing. So if you were living in the middle of Topeka, on 21st Street or Fairlawn or something, you wouldn't let the critters run loose like that. But out in the areas like this, it's much, much different. So Poe coming out to greet Mom is not an unusual thing. But watch this. This is the extreme wind and what may be a gustnado coming through Sabetha right there. Look at all the dust kicking up. And Poe comes out just the exact wrong time, because that's when the worst of this hits. And you'll see over here, the top of this shed actually gets blown off the end of it. There it goes. It's blown off. The winds are at least 80 miles per hour. Poe decides, I'm going to go back in. And here's another shot from Debbie's building there from security camera. You can see right there the roof of one of these buildings gets blasted off here in just a moment. And here we go. I'm waiting for it, unless it already blew off and I didn't see it. So, there it is over here. That's the roof of that building that's blown off in these 80 mile per hour winds I think it was on the southwest side of town, actually, in Sabetha. So again, we had a warning for that area, and overall the damage path of this is about 33 miles, almost 33 miles, which is very unique. And microburst situations, you tend to see them for about 2 to 4 miles at the most. They tend to be maybe a couple of miles wide. They do not tend to go on like this, but almost surely this is a series of microbursts, and from what I've looked at from the radar archive, it looks to me like it may be something that's kind of a wave, where you had the powerful winds in the middle of the atmosphere coming down to the ground. It kind of bounces back up and then comes back down, and it just ripped up a lot of things all the way from Bern and Sabetha all the way down to Frankfurt. So really a wild situation. But again, some of the similarities there to what I saw from this dust storm we had back in Topeka in 2018. So I had a couple of questions from people here that I'll answer here real quick. Somebody's asking me, Vincent asked me, has climate change affected our weather patterns in Topeka over the years? Any noticeable trends in temperature or extreme weather events? You know, and I can't say for sure that there is specifically in Topeka. When you're looking at you know, climate change, things like that, you have to look at kind of larger areas. You know, if you just look at one city in particular, you know, that's not you know, that's not a real accurate way to look at it. But I can tell you things like this. For example, I'm not talking about what causes climate change. I'm not going to get into the debate of all that. But for things like Hurricane Helene, which clearly people are familiar with, the Gulf of Mexico temperatures earlier in the summer, there was one buoy that actually registered 100 degrees in the water. So that's unusual. If you have the ocean water, the Gulf of Mexico temperatures hotter than they normally would be, then it is going to influence the overall weather pattern, no doubt about it. You know, and we have seen, you know, globally temperatures have been hotter every year the last few years, but that's the big thing to really watch is those ocean temperatures. When they start to really creep up, that's the thing that really makes a massive difference, even for us, because the warmer the Gulf of Mexico is, that's a source of a lot of the moisture that creates a lot of the precipitation in our area. Not all of it, but a lot of it. So the warmer the Gulf is, the more moisture we get our way that can create storms and storm energy. Next question, somebody, Hawks as the bird on Twitter says, what would I suggest as a field for somebody to study to become a meteorologist? If you want to become a meteorologist and do what we do, you know, one of the things you can do is I believe KU has a meteorology department. You can study atmospheric science there. OU, Oklahoma University has one. I know Josh Duncan from Topeka was studying there. He got his degree from OU. University of Missouri, I know a lot of fans around here, Mizzou of course, but University of Missouri has a good meteorology department. Florida State University does as well, and University of Colorado in Boulder does a lot of work as well. So anyway, those are a couple of questions we had. But again, just kind of a recap of all the wild stuff that happened on October the 30th, and a little similarity, I think, from the storm we saw back in Topeka in July of 2018, when another one of these microbursts combined with a lot of dusty conditions from the extreme drought, and it just made for an absolute mess. So that's what I've got. Hope you have a great weekend. I'll see you tonight on 13 News at 10.